In this section, we're going to talk a little bit more about why we can use fraction arithmetic to calculate probabilities. And we've just kind of done it on faith before, but I'm hoping that this section will show you a little bit more of how these calculations actually work. So in this experiment or this situation, we are rolling a die 2 times, and we want to know what is the probability of getting 2 2s from rolling that die 2 times. So this is an independent compound event because we have 2 rolls of the dice, and the first roll is not dependent on the second roll. It's not like we're removing the 2 from the die or something when we're rolling it the second time. So this is an independent compound event. We could draw out a tree diagram of this. It would get pretty large, but we can think about the probability first of getting a 2 in the first roll and the probability of getting a 2 on the second roll. So we have 6 numbers on a regular die. So our probability of getting a 2 on the first roll is 1 out of 6. And then our probability, because this is independent, we didn't remove anything from our dice, the probability of getting a 2 on the second roll is also 1 out of 6. We can multiply these together and we get 1 out of 36. Now, we can also, we've seen this before, right? This is nothing new. But we can also model this using fraction multiplication. So here, our rectangle up here represents all the experiments that we could possibly have by rolling a die. So in this case, we could roll a 1, a 2, a 3, a 4, a 5, a 6. So that's why we've divided our rectangle into 6 equal pieces. Equal because we have an equal chance of getting either a 1, a 2, a 3, a 4, a 5, or a 6. In this case, we want to roll a 2, so the shaded in region represents the probability of rolling a 2 on the first roll. So that's 1 out of 6. Now, when we get to the second one, we can again divide our box up into 6 equal pieces. And we see that what has happened here is now, and you can count them if you don't trust me, but now we have 36 possibilities. And we could shade this whole section in to represent, again, getting a 2. But remember, we wanted to have a 2 for the first one and a 2 for the second one. So this intersection down here actually represents the probability of getting a 2 for our first roll and then a 2 in our second roll. And it is actually 1 out of 36 boxes on this drawing. So that's one way to represent an independent compound event as fraction arithmetic.